Hello and welcome to TidyX episode 168. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for checking in. TidyX episode 168. We've been talking about base R plots.
Mm-hmm.
And so today, I think we're probably getting to the wrap up of base R plots and we'll move on to something else. If you have something that you want to see, or perhaps you want to see more base R plot stuff or base R plots in Shiny, which is also doable,
Yep.
like and subscribe, comment on the YouTube channel. Let
Let
us
us
know
know.
if there's something you'd like us to cover in the new year. But here we go, episode 168. We are going to do kind of a quick review, housekeeping
You
of the
know?
base plots that we reviewed over the past 4 weeks. And then we're going to show you some really cool kind of interactive base R plot, sort of like I'll call it like Plotly-esque, but not really Plotly, but some interactivity with base R.
Yeah, some fun interactivity. This is kind of nice to be doing a review. Been seeing a lot of posts. It's the end of the year right now. We're recording this day before New Year's Eve. Tomorrow's New Year's Eve when
Yeah.
this video will be coming out here. And there's a lot of year in review going on right now, looking at what's happened in this past year. And I think TidyX has had a pretty darn good last year here. I've been really enjoying doing this series, so I think it's great that we're going to be taking a moment here and going over what we hope you've taken from these last several episodes here. So with that, let's get started here. We're loading the Lahman package, which is a great data or a package that has a ton of great data sets on baseball. We're going to use the batting data set from that. We're going to be filtering to keep all batters that batted between 1980 and 2004 for those seasons. And we're going to be keeping player ID, league ID, at bats, and hits. We're then going to be calling the drop levels because there's some factor levels that exist in hitting that are not relevant to these years. Then we're going to call the aggregate function, and this is kind of like a combination between a group by as well as a summarize in Tidyverse. So what we're saying is we're going to be taking by player ID, we're going to combine, right, cbind, at bats and hits, and use the hitting data set here. And when you find multiple values, you're going to sum those values together. So when we call that on hitting, let's take a quick head of hitting down here on the lower left here. So we've got at bats and hits. And so we've now basically consolidated all this information. So for every player, we have all of their at bats and hits and all the information that we've got there.
Hmm.
And then we're going to use this with function. And we're going to pass the data set that we're going to want to be calculating something over. And then the second argument is the values that we're going to be using, the column names that we're going to be calculating values on, right? So this is kind of similar to a mutate-esque type deal here. So we're going to say divide hits by at bats, and we're going to assign this back to the BA or batting average field inside hitting. So we can run that now. And then we're going to say, you know what, but actually, we don't really want to keep any individuals that batted less than 1,000 times because for our purposes in our data set, they're not going to be very useful. So sorry, guys, you're out of here. Let's subset hitting any values where AB are greater than 1,000. Keep those records there. And so there we go. Now we no longer have 0 at bats and 0 hits. Which obviously would then, if we were dividing by 0 divided by 0, gives us, weird things. So that is our hitting data set, but we're interested in a couple other data sets from Lahman. Patrick, do you want to take us through those and what we're doing with them?
Yeah, we want to get the actual player names because as you can see, hitting is only tagged by player ID. And we want to get some information about whether or not the players made the Hall of Fame and how many Hall of Fame votes they got. So the player data, all the biographical data about a player is located in the people data set, of which the columns we care most about are player ID because we're going to want to be able to join this back to hitting data. So that's kind of the key variable, the key variable that we're going to be able to join across. And then we want name first and name last. So we're going to get a little first name, last name. So when we run that, we get that data and we create this new name variable where we're just going to paste together name first, space, name last. So that's really easy to do. And then we don't really need the name first and name last columns. Of course, we could leave them, but why bother?
Yeah,
Oh,
there's not really a need for them.
what happened there? Did we not?
I don't think select.
Oh, select might be a tidyverse function, I
Yeah,
think.
what we can do
And
is
put it
apparently
in
I didn't
brackets.
pay too close attention when we were going
There
over
you
this. We can just do that. Nope, that's not it either.
go. No, why did that work
Here, we
either?
can just do, because we know the
By
index is,
3. Mm-hmm.
we can just do that. And then there we go.
Easier. And so now we have a data frame that just has the player ID, which is our key join column, and the player's full name, and then Hall of Fame information. So this is all of those players and whether they were inducted into the Hall of Fame or not, and how many votes they got. So again, we need to retain player ID because we're going to use that as our join. Now we have yes or no. Inducted is a binary column, yes or no, a Boolean variable, and then the total votes. So the total votes that they got that year, and that data set has other information like how many potential votes there were and things like that.
Yeah,
So we
there's
left that out because for the purposes of our plots, it wasn't important. So now we do a little merging. So this would be like left join or right join or full join in tidyverse. We do merge. We're going to merge the hitting data with the player's data. By.x is player ID and by.y is player ID. You can leave those out since the column name is the exact same between the data sets. It will do this automatically. I just like to put it there so that I'm explicit and I know exactly what I'm joining on in case there are other columns. Or maybe in one data set, player ID is with a capital P, and in the other set, it's with a lowercase p. And I want to make sure that we join on those columns explicitly. So yeah, exactly. Could be named something totally different. Exactly. So I just always put that in when I do a merge just to make things explicit. Now we have a final data set that has information about the career at bats, the career hits, the career batting average, the player's actual first and last name, and then whether they were inducted into the Hall of Fame, and then some votes. And so the number of votes that they got when they were up for Hall of Fame nomination. And so now let's do a little bit of plotting review. Ellis, want to get us started?
Let's do that. So one of the type of plots that we went over the other week was a bar plot. And a bar plot allows us to compare values by the length of the plot, or the length of a bar representing the values that we want to be plotting here. So what do we want to pass into that? So let's generate a proportions table. So to do that, we're going to take the DAT data set and pull out the inducted column there. And if we throw that into a table, that gives us the total number of counts for yeses and nos of individuals in our data set that got inducted into the wait, let me quickly double check here how large DAT is. Dims
Yep. Dim dat.
DAT. Let's dim DAT.
Dim dat.
Okay, so that quickly, not thinking too hard, that does look like that might be potentially a little bit smaller. So we potentially have some individuals that
Might be
batted
some edit.
enough that were not up for voting for the Hall of Fame.
Yeah, it could be in the years that we included, you have to be 4 years retired. So there could be players that are still playing in our data set. Another way you could check whether these are equal is you could take that table function that Ellis wrote 2 lines above and wrap the word sum around it. And that'll give us the total. Yeah, there you go. If you just wrap sum around that, it'll add up the total observations. And we actually do have because I think I filtered out
Oh,
by a
yeah,
year.
dim.
Yeah,
Dirt.
I think I filtered out by a year.
No,
Uh,
you're good.
yeah,
That's the number of columns. I just had a
yes,
mental block there.
523 rows.
All
Yeah.
right, anyway. So let's ignore that distraction here. My bad. And so now we're going to throw it into, so we have this table of yeses and nos. Then we're going to do prop table. So this is going to calculate the proportions based on the vector that you enter in here. So going from 485 to 38, it becomes the actual percentages. You technically could divide by n rows of dat, but this is going to be a little bit more reliable for you if there's any other weird situations that happen. So
Yeah,
let's throw
missing
that.
values or something like
Yeah.
that.
So then, of course, if we want to set the title, we set main equals and then the title here, and we get our handy dandy bar plot here. And this is the percentage of players inducted into the Hall of Fame from the data sets that we have here. So not unsurprisingly, the vast majority are voted no, and a very small proportion are voted yes. Because if everybody's a Hall of Famer, then nobody's a Hall of Famer, right?
That's right.
Um,
Got to mean something.
yeah, the next type of thing that we might look at is what is the proportions of the votes that people got when they were up for voting for the Hall of Fame. So everyone in theory got some level of voting happening for them. They were nominated and people had to vote for them. So what does the distribution of votes look like when somebody goes up to potentially join the Hall of Fame? And so if we look here, this is we call the hist function on the vector votes. So these are for every individual. What are the number of votes? Of course, there's some people that got 0 votes, some people that got 1 vote, 10 votes, 206, 523. And so you can see oftentimes individuals get a very low number of votes for them, which would then match with the large percentage of people that don't get into the Hall of Fame. And then as time goes on, because the number of votes, there's a certain a number of people that are voting for it, and I believe that's increased over time. So you could maybe say that number of votes is not the best way to look at this, but we wanted to look at a distribution of this and how some people got, up nearly 600, somewhere between 550 and 600 votes. And so clearly everyone agreed that this person should be in the Hall of Fame. But maybe down here, there's either less potential voters or there was not as much agreement in whether this individual should go into the Hall of Fame or not, because they don't need to get 100% in order to go into the Hall of Fame.
Mm-hmm.
So then, what if we wanted to look at? What if we wanted to look at the density? So what does it look like between the individuals that did get into the Hall of Fame versus not when we look at their batting average? Patrick, do you want to take us through this?
Yeah, so for this, we're going to use density plots, which are going to be line plots that are essentially conveying similar information as the histogram, except that they're reporting it as frequency instead of total counts. And of course, you can do frequency as histogram as well. We did that in the last episode if you want to review that. So here, we're going to use the plot function, and within it, we call density over the batting average, where we've filtered out players that have not been inducted into the Hall of Fame. So this is going to be the batting average of the players not inducted into the Hall of Fame. It's a density plot, so there's only an x-axis variable because the y-axis is automatically going to be a frequency. We're going to make this a rather thick line, LWD3. We're going to color it red. We're going to explicitly set the x limits from 0.13 to 0.37 so that we can get the full distribution of both this density plot and the one that we're going to overlay with it. And then we set a title. So this is the distribution of batting average between those that made and did not make the Hall of Fame. And the x-axis label is going to be called batting average. So if we run that, we get our first plot, which is kind of choppy, but we can see what it looks like for the players that did not make the Hall of Fame. In order to add another density plot over this, we don't call plot, we call lines. So now that plot has been called, everything we do from here on out until we call plot again, or until we call dev off, is going to be layering on top of this canvas. So here, we're going to use the lines function, and we're going to say, hey, let's do another density plot. This time, we want this one to be the batting average of those that were inducted into the Hall of Fame. Go ahead and color it blue, make it a similar width or similar thickness of the line, and make it dashed so that it stands out a little bit more. Very cool. So you can see this is a much smoother density plot, and you can also see the little blip at the bottom, and those are the pictures because we didn't filter out pictures at the beginning, which is okay. Pictures are Hall of Famers too. Finally, we're going to add a legend. We're going to put that legend at the top left because we can see from our canvas that the top left has a lot of nice open white space where we can throw things in there and descriptive information. We're going to make the legend say, did not make the Hall of Fame or made the Hall of Fame in the same order of our plots. And then we're going to make sure that did not make the Hall of Fame was a solid line and did not make the Hall of Fame was a solid line. Did make the Hall of Fame was a line type 2, which is dashed. And remember the colors. So notice that the legend words that we choose, they're in order, and the order has to remain the same for how we want the legend to be shown. So we want a solid line and a dash line. We want a red line and a blue line. And when we run this, we get a nice little legend at the top. And now this is a pretty cool looking graph. Another way we can show distributions of data is a strip chart. We haven't shown a strip chart before. A strip chart is just basically a whole bunch of dots in one single line. We put jitter here, just like you would do if you were doing like geom jitter or something like that in ggplot. If we don't put jitter, it's just going to put dots overlaying each other. But we want to see the density of data. And in this case, we're going to look at bats. Strip chart is a really unique type of plot. You can't add anything more than one color to it. So we can't have Hall of Famers and non-Hall of Famers on the same chart. I mean, we can, but we can't have them colored. So we're going to actually use par. So the parameters of the plot, we want MF row is telling this plot that we want 2 rows and 1 column. So we're going to stack these strip charts on top of each other. The first one is going to be the at-bats of only those inducted into the Hall of Fame. We're going to color it red. Again, the method is going to be jitter. PCH 19, remember, is the solid dots. So we don't want dots that were open. The x-axis is at bats. This is going to be a single x-axis type plot, just like the density plot, just like the histogram. And the main title is going to be strip chart of all at bats for Hall of Famers. We're going to do the exact same thing below it for the non-Hall of Famers, or sorry, for everybody. So instead of non-Hall of Famers, we're going to just compare to everybody. And so we could see the density of at bats for the whole population. And then we can see the density of at bats extracted out for only the Hall of Famers. And again, because we're in this specific canvas, if we don't turn the dev dot off, we're going to have this 2-row plotting canvas carry on as we add new plots. So we're going to just go ahead and turn this off using dev.off. And now let's talk about dot plots. So let's get into some things with text and interactivity. Ellis, why don't you take us through the text plot?
Sure, I'll get started on that. So, because this is the text plot, we obviously can't have every single player recorded in this plot. That's way too dense if we're going to be doing something with text that we need to be seen. We should be worried about overlaying and the different pieces of text being shown, and then it just becomes a hot mess and you can't read it. So let's filter down to keep those. I think it was 37, 38. The number of people that were inducted. So let's do that. Let's quickly print that out so we see all those people there. Hey, isn't that wonderful and beautiful? So let's create a plot. So we're going to say the x-axis is at bats for the DAT inducted, which is all the individuals that were inducted. Then the y-axis is the batting average. We're going to set the dot type to be 19. They're going to be zoomed in a little bit. The X label will be AB, the Y label will be BA, the title will be BA tilde AB, and the type is N. And this is important because when I run this, we didn't get anything. And that's because I said type equals N. And that's going to not have it show any of the values in the plot. There's no points, there's no nothing. Technically, I really didn't even need to do that. I could have just done that. Right? And so now it's going to generate the outline of the plot, but none of the content in it. Because I'm wanting to add text. And lo and behold, there's a helpful function inside of base R called text. And it works very similarly, where the x-axis or the x entry is the location in the x-axis you'd like the text to be shown at. The y entry is the y-axis that you'd like to have content added in, and then finally there is a labels argument, and that is the text you'd like to be shown for each of those locations. So here in this case, we've set again the x-axis to be at bats, the y-axis to be batting average, and then labels is the name of the player. So now when we run that, we can see roughly where everyone is at, where Tony Gwynn has a high batting average and a fairly high at bat. So you can also be pretty confident that is his true batting average too, with that number of at bats. Like this person hits well. But one thing you may notice is over on the right here, Cal Ripken, some of the folks down here who were pitchers, their names are getting cut off. And that's due to just like the way that the canvas is laid out. The text isn't going to be showing outside of the bounds of the inner plot here. But we can update that using the xlim argument here. So let's add that back in. You add that into the plot, because this is setting your canvas that you're printing everything onto. So let's add that in. Let's make that a comma, not a dot, and run that. And as you can see, this view is already a little bit larger. Then we throw in text, and there you go. You can now see all the names shown very clearly within our it's kind of a scatter plot combined with the with a point plot or scatter plot.
Mhm.
But the downside of this is you obviously have to then limit the number of points that you or names that you're including in your plot, because you can't show everybody. Even with this, even though we subset down, there's several spots there, and right here, and then over about 2,000 at bats, where there's a number of different players where their names are now overlapping, and that makes it a little bit difficult to see who exactly are those batters or the players, what's going on there. So let's figure out a much more cool way that you can show the names of the players that you can inspect this using only base R. Add that like cool plotly functionality that everyone loves, or interactive viz capabilities into base R. Patrick, can you show us this really cool plot technique?
Yep. So the general overlay of the plot doesn't really change here. We've got the at-bats on the x-axis. We've got batting average on the y-axis. PCH is going to be 19. We're going to color it by whether the person was inducted or not. CEX 1.3 is going to give us slightly bigger points than the default. We're going to just give a crafty name to the x-axis and the y-axis. On the main title here, we're going to be saying, hey, we're regressing batting average on number of at-bats. \n means that we want a second line. And on that second line, we're saying to the user, go ahead and click 2 dots to identify the player's name. It's going to read it back to you. And the xlims are the same as before, 500 to 13,000. So if we run that, we get a dot plot. Okay, great. Let's make sure that our legend is descriptive, because we do have 2 different colors of points. So if we run the legend, we're going to put it in the bottom right, because again, there's a lot of white space down there where we have room to kind of throw things in. We're going to make sure that the PCH is 19. It's representative of the dots that are actually in the plot. And we want to make sure that the legend reads correctly in the correct order. So we want did not make Hall of Fame first, then made Hall of Fame. And we want to make sure it's black and red as our point colors. Now, how do we make this interactive? Let's say we're looking at this plot and we're like, hey, who are those guys at the bottom? Or who are the guys at the far right? Identify gives us this interactivity. So basically, to make this run, we just use the same X and Y axis passed to it that we do for the plot. And then we pass to it the parameter that we want to be identified. So in this case, it's name. We could have put something else there. We could have said dat identify the at-bats or identify the number of hits. But in this case, we put in the label's name. I do wonder if you could do like paste name to, let's say, uh, hits, separated by, well, yeah, yeah, something like that.
Or
And
it would
that each,
that do we have hits in the data set still?
I
Yeah.
believe you, yeah.
Yep.
So if you
That.
did def H and maybe, yeah, yeah.
Let's just try that. Keep it simple, right? We're already
Yeah.
going off script.
There. And then N is two. That's just identify like, hey, we're gonna let the person click on two different people. So go ahead and hit that. And let's see if that
And so
works.
now you
So
may notice when
yeah.
I mouse over into the canvas area, rather
Yeah.
than being just a normal mouse, it's now got these crosshairs.
Yeah.
So now let's go and look at these two folks down here. So I clicked once, you saw that little point showed up, and I'll click again. There we go. Pasting
Yeah.
does work.
That's pretty cool. And then if you want to run this again, you have to run the plot function again.
I think you
Um,
can run identity
oh,
again.
you might be able to just run it. Yeah, that's right.
Yeah.
Yeah,
And
that's
I've
pretty
updated
cool.
this to do the new line so that hits shows up on a new line.
And you run it again.
So this would be a way that if you're using base art and you wanted to add some interactivity to your canvases, this is how you can
Yeah.
do this.
And so you could envision a setting where you maybe build a Shiny app and you have a little button that says like add two new players or refresh, which basically wipes away all the names on the canvas to clean it up and things like that. Like there's probably lots of cool options you could do with some observe event buttons in Shiny that would allow this to take on kind of a new level of interactivity with more options.
Yep, exactly. Without having to lean into and then bringing along with it the need to have all the JavaScript libraries and all the other packages.
Correct.
Again, a lot of this, the reason that we're going through a lot of this isn't because we don't find the other tools valuable. We do. We like them. We think they're really, really cool. But you don't always have access to them for one reason or another. And whether that's just because that's the way your team works and just because you want to use them doesn't mean that you get to force the rest of your team to learn your way of doing things because you're not willing to change. It's more being aware of all the different techniques that exist so that when it comes time to use them, you're like, oh, I know that, or at least I've been exposed to it a little bit so that I can apply that in my own work. And there's less of a learning curve to go along with that. And that's why we think there's a lot of value in knowing these techniques is to be able to um, be more flexible and be curious about this language that we're using. And there's a lot of different ways that it can be used that maybe you're not always exposed to. Sorry, getting off my soapbox. um,
Makes sense.
and then one thing that we also found too, and this was while we were troubleshooting and testing and building out the code and whatnot, and it worked on Patrick's computer, and then it didn't work on my computer because I had my RStudio zoomed in at a different zoom than 100%. So I'm going to rerun this code again, and so we're going to open up an issue for Posits RStudio so that they can try to fix this. But if you see here, I run like this, and I click over at Cal Ripken, and then I forget this other fellow's name, Ricky, pops up, wonderful there. But now if I zoom in, and then I rebuild the same plot, it looks, it looks mostly the same, but it's not perfectly identical. But now when I click on these two, it's actually getting Mark Grace and Tim Raines. And so I think that's just due to the way that the canvas is built. Because we zoomed in, it changed some of the math that needs to happen in the back end, or the canvas is now weird. I'm sure when we raise this, that they'll be like, "Oh, it's this," and then kind of go from there.
Yeah.
Um, so this bug that we saw right now may not exist by the time you guys are seeing this. If you watch this far into the future, um, but we just wanted to call that out in case you came across this as well, and you're like, "It's not working for me." Check your Zoom. So, with that, and nearly 30 minutes later, I think we're going to call episode 168 of TidyX. Thank you all so much for a wonderful year. As always, you can find me on various social media sites at Ellis_Hughes. Ellis_Hughes.
And you can find me on Twitter at OSP Patrick at tidy_explain is where the screencast lives on Twitter. Of course, easiest way to get in touch with us is to hit us up on the YouTube channel, like, subscribe, drop questions, comments down below. If you've enjoyed our work this year and you feel like it's helped your work this year and you'd like to donate to the show, we do have a Patreon page. We're always grateful for anything that you'd like to donate. That said, thanks so much for Tidy Explain 2023 signing off. Happy New Year to everyone, and we will be back next week, I think, with the first episode of Tidy Explain 2024.
There we go. Thank you all so much. Keep on exploring your world.